Right now, as you're watching this video, over 60% of stars exist in binary systems, but you only see one shadow. The first confirmed planet orbiting two stars, Kepler 16b, proved that worlds with double shadows actually exist. But that's just the beginning of what we've discovered about planets that break Earth's rules. The James Webb Space Telescope and TESS have confirmed worlds like HD 189733b, with sideways metal rain moving faster than bullets, Kepler 138 with ocean layers thousands of kilometers deep, and Corot 7b, where vaporized rock condenses into solid precipitation. These discoveries reveal three categories of impossible phenomena: binary shadows that shift throughout alien days, ocean worlds deeper than we ever imagined, and exotic weather that turns physics upside down. What you consider normal about Earth is actually the cosmic exception. Multiple shadows on binary star worlds. The first place to understand this cosmic exception is in the binary star systems that dominate our galaxy. Over 60% of all star systems contain two or more stars locked in gravitational dances around each other. These binary and multiple star systems are the norm, not the exception. Our solitary sun makes us the odd ones out in a galaxy filled with stellar partnerships. The Kepler Space Telescope and TESS have now confirmed over 80 circumbinary planets, with statistical analysis showing that roughly 1 in every 12 binary star systems hosts at least one planet. These aren't theoretical worlds anymore. They're real places where the fundamental experience of existing would be completely different from anything you know. Each new discovery reveals more about how these complex systems actually work. Standing on Kepler 16b, the first confirmed circumbinary planet discovered by Kepler, would immediately show you how strange these worlds really are. This planet, roughly the size of Saturn, orbits two stars that are locked in their own cosmic waltz. One star burns orange-red while its companion shines brilliant white. As the planet moves through its 229-day orbit, the relationship between these two light sources creates shadow patterns that change constantly throughout each day. Your shadow wouldn't just move across the ground like it does on Earth. It would split, merge, disappear entirely, and reappear as multiple distinct shadows depending on the positions of both stars. The orbital mechanics that make this possible challenge everything scientists thought they knew about how planets form. For decades, researchers believed that the gravitational chaos of binary systems would prevent planets from maintaining stable orbits. The competing gravitational pulls should tear apart any forming worlds or fling them into deep space. Yet these planets exist and maintain stable orbits for millions of years. Computer simulations now show that planets can find gravitational sweet spots where the pull from both stars actually stabilizes their orbits rather than destroying them. Each day on these worlds brings multiple sunrises and sunsets as the planet's rotation reveals and hides each star in sequence. On some binary planets, you might watch the orange star set in the west, while the white star continues to burn overhead, casting your shadow in a completely different direction. Hours later, as the white star approaches the horizon, the orange star might rise again from the east, creating a second dawn before the first day has truly ended. The concept of a single 24-hour day becomes meaningless when you're dealing with two different light sources that operate on their own schedules. TOI 1338b, confirmed as the first circumbinary planet discovered by TESS, demonstrates another variation of this shadow complexity. This world, roughly 7 times the size of Earth, experiences even more dramatic shadow shifts as it orbits its binary pair. The changing angles between the planet and its two stars create periods when shadows appear sharp and distinct, followed by times when multiple overlapping shadows create complex patterns across the surface. Navigation on these worlds would require completely different methods than anything developed on Earth. Among the 20 to 30 well-studied binary systems, traditional sundials become useless when multiple shadows point in different directions at the same time. The concept of using the sun's position to determine direction breaks down when you have multiple suns that move independently across the sky. Any civilization that developed on such worlds would need to create timekeeping systems based on the complex interactions between multiple light sources rather than the simple rotation of a single star. The daily rhythms of life would be completely alien to anyone from Earth. Instead of the familiar cycle of day and night, these worlds experience periods when multiple stars shine simultaneously, creating intensely bright conditions where shadows appear sharp and distinct. Other periods bring partial darkness when only one star remains visible, creating dim twilight conditions even during what would normally be considered daytime. Some binary planets experience true darkness only when both stars set simultaneously, which might happen just once during each orbital period or not at all depending on the planet's axial tilt and orbital characteristics. Temperature variations on these worlds follow patterns that make no sense from an Earth perspective. A planet might experience its warmest period when both stars shine directly overhead, creating intense heating that far exceeds anything possible with a single star. Conversely, when the planet's orbit carries it farther from both stars simultaneously, temperatures might plummet rapidly. These temperature swings happen on timescales completely different from Earth's predictable seasonal changes. The implications extend beyond just shadows and temperature. Photosynthesis on these worlds would need to adapt to light sources with different spectral characteristics. Plants or plant-like organisms would need to handle the orange-red light from one star and the bright white light from another, possibly at the same time. The evolutionary pressures on such worlds would create life forms adapted to multiple light sources rather than the single spectrum we're familiar with. What makes this even more mind-bending is the realization that our single star system is actually the cosmic oddity. Earth's simple pattern of one shadow following you around during the day is unusual in a galaxy where most worlds experience the complex interplay of multiple light sources. The familiar rhythm of single sunrises and sunsets represents a minority experience in the universe. These binary worlds aren't rare exceptions or exotic curiosities. They're the standard configuration for planetary systems throughout our galaxy. The strange worlds are places like Earth, where planets orbit alone around solitary stars, creating the simple shadow patterns we consider normal, but which are actually quite rare in the broader cosmic context. But shadows are just the beginning of how alien worlds break the rules we think are universal. Ocean